Hello everybody. So this will be assignment 1 for CS302 for spring 2022. This program is going to be sort of writing bubble sort for a doubly linked list. And of course sorting is one of those very celebrated, simple yet complicated topics in computer science theory. So what we're going to do is I'm going to first go over our linked list class. So we're going to create a class that will implement the linked list. I'll go over details as to how to write some of the functions later on. And of course, I'll sort of discuss a little bit of main towards the end of this video. So not much to discuss here. So let's go ahead and now get into the linked list class. And before I go into the assignment, I'm using the light theme PDF. I know for some people they prefer a dark theme, but what I've seen in the past is some students are not able to read the PDF in the dark theme mode. So I guess, you know, if you're a dark theme person, the light theme will just only burn your eyes, but you'll be able to at least read the PDF. So this way it kind of covers all students. But of course, for all my assignments, I always will have a dark and light theme for every assignment. So for linked list class, we're gonna, of course, it'll be a templated class. I'll use templates here and there because it's a good practice to use templates and it makes your code more reusable potentially. So we're gonna have a linked list of some template, and of course we're gonna be using integers for our assignment. But the idea is we're just making a template just to kind of make it more generic. And then we have our struct node right here, and this node is going to basically it's going to store all the data in each element or each node of our linked list. So we have our type data, node star previous or prev, and node star next. So we can visualize this in the following way. So let me go ahead and go to one node, which is typically in dark theme, but I'm going to be consistent here with all of this. So let's go ahead and I'll just draw an example, just an example linked list. That's how we can visualize it in our program. So I guess I'll use a larger box like this. You go ahead and sort of copy and paste this a couple of times just to sort of try to show you how this looks. I mean, I'm guessing you were exposed to linked lists back when you were in CS302, but just in case, I'll go ahead and now discuss it here. So here's how we can visualize the struct node. So each of these boxes right there, they're going to be essentially nodes. In the middle, so this area here, this middle spot, that's going to be your item. This is going to be your previous field is going to be your next field. So we can have the following setup like this. And then this would be a null. This would be null as well. And typically for a doubly linked list, we'll maintain a head pointer and a tail pointer as well. So head would point to that first node and tail points to the last node. And of course, we'll for right now make this a linked list of integers. So we can assume we have the following 7, 5, 3, 8. So each of these boxes will be a node, and a node contains 3 fields, some data field, a pointer to the left neighbor, and a pointer to the right neighbor. So that's how we can look at this. Let's go ahead and go back to our, let's go ahead and just go back to our PDF. So that's going to be our struct node. So now I'm going to talk about the rest of the linked list class. So these discuss this kind of briefly. Before I go into iterator content, I'll go over the swapNodes one at the very end. So basically in our linked list, we have our head and tail pointer, which I already said before. The head points to the front node and tail points to that last node. And then we have this constructor right here, default constructor. Just simply sets head and tail to null. Easy peasy. This will be our copy constructor. So basically what's going to happen is this copy constructor is going to be taking in sort of a linked list of type, and you want to do a deep copy of one linked list to the other. So hopefully this is kind of review from 202, but we're going to just simply do a deep copy of the linked list. And an assignment operator, similar idea. You want to do a deep copy. So this parameter right there. So remember, if you remember assignment operators from CS302, you had the equals operator, then you had the right-hand side, some object. In this case, it'll be a linked list object, and you want to do a copy of that into the left-hand side, or this object. So it's just that standard deep copy assignment operator. And of course, we'll have our destructor right here, which will just deallocate our entire linked list. Remember how deallocation works for linked list? It's like playing Pac-Man. You just do several head deletions. You just sort of deallocate one node at a time, basically. If you remember that from 202. So basically, and of course, last one here, we have our tail insert, which is we're going to be taking in some value into this function, and we're going to allocate a node to the end of our existing linked list and assign that end node's data field to be whatever the parameter is in this function body. So there's some examples I have here in the PDF for tail insert. Let's go just look at these for a second. But of course, here's the actual function descriptions given to you right here, so you can read through that as well. So I'll go over iterator's content later. But anyway, for right now, we can assume we have like this. So here we create a linked list of integers. And then when I say list.tailInsert1, then what happens essentially is going to create a node where that single node by itself will contain the value 1. Then if I do a tail insert 2, so let me just go ahead and draw this here in the PDF if I can. I should be able to. So let me just go ahead and do a very quick view of this. But if I tail insert 1, I would have this in my linked list. And of course, remember, head and tail both have to point to that node. Then when I say list.tailInsert2, well, then what's going to happen is it's going to insert 2 to the end like this. And 1 points to this, 2 points back. And of course, tail is now going to be pointing to that node. Then you can imagine, of course, tail insert 3 would insert 3 to the end and so forth. So that's sort of how the tail insert works. So I went over the very basics of the linked list. So now I'm going to go over the iterator content next. All right, so let's go to our iterator, which this is something you might not have learned in CS302. So the iterator class is actually a class defined within our linked list class. We have a nested class structure. It's not really actually uncommon really in object-oriented programming, but you might have not been exposed to this just yet, or haven't been exposed to it before in CS302. So the iterator class is really going to be just really a pointer on steroids, if you will. So essentially it's going to behave like a pointer in main. It'll allow you the flexibility to traverse each node without really using pointers in main directly. Let's go ahead and just first describe these functions over here. Then I'll go ahead and do an example of these to sort of help us understand how iterators actually work. So this friend class LL, all that means is if I were to create an iterator object within any of my linked list class functions, I will be able to access any private members of the iterator object. So in this case, we have node star current defined within our iterator class. So that means if I were to create an iterator within tail insert, let's say, I would be able to use an iterator object within tail insert and use a dot operator to access that current field. You might not really have to do that anyway, but I guess this is sort of, why not, essentially. So for iterators, we have this node star current. This is going to tell us which node the iterator points to. And then now we have our public members. So this constructor, well, it's going to set current equal to null. That's all. The second constructor here is going to take whatever pointer you pass into this function, is going to assign that to current. Type operator star, well, this is going to kind of emulate this dereferencing for iterators. So the star symbol for pointers dereferences, here it's going to be an operator, but what it's going to do is this star operator star function simply will just return current arrow data. It returns that data field of that node that current points to. Then we have plus plus and minus minus. Well, those two functions are going to simply set the current to point to the next element or to the previous. So plus plus would set current equal to current arrow link, or sorry, arrow next. Operator minus minus is going to simply set current equal to current arrow previous. And that int right here at the very end, that's only because you want this to be a postfix operator. So this plus plus actually would appear after the iterator object. And then this equals equals and not equal, simply all we're doing is going to compare this current with this object's current. We're going to compare those addresses. If they both point to the same node, return true, else return false. Not equal, what it's going to do is, well, it compares this current with this object's dot current. If they do not point to the same node, it returns true, else returns false. And I'm going over here back to my linked list class, iterator begin. This function will simply return an iterator object whose current is equal to head. Iterator end is going to be a function within this linked list class that returns an iterator whose current is equal to tail. So now that I went ahead and sort of went over this iterator content, let's do an example of how to use iterators. I do actually have some code given to you as well in this PDF, but I suppose I can also go over it here just because, well, it is in the video, of course. This way it's more somewhat interactive, I guess, if you will. Let's go back to the to OneNote. So consider this linked list. Let's say, for example, I went ahead and I said ll int, and I call this list. So all of this entire thing is going to be all within my list object, basically. So within list, we have a head and tail, and head and tail are going to point to the first and last node in my linked list, and I'll be able to traverse these nodes. But this is kind of our list object, essentially. And of course, to create this, I would just say list dot tail insert 7. I'm going to try to copy and paste this. This is one of the benefits of using OneNote over using a whiteboard. Okay, this actually works nicely. Okay, awesome. Okay, and there we are. So we would have basically, I'm going to erase these guys here. So you would have 5, 3, and 8. So these 4 function calls would essentially create this linked list. Okay, so I would like to be able to traverse this linked list. So in CS302, you might have actually used pointers, and pointers are great. We really value pointers. We embrace pointers in C++, and of course then we learn how to try to cover up pointers, which I guess that's kind of how life goes sometimes. So let's go ahead now and create an iterator object. Now this is a little bit strange. So if I want to create an iterator object in main, I would have to do ll int. I should probably make this a bit more nicer. There we go. And we're going to have this scope resolution operator because this iterator class is defined within linked list. So we have to first say linked list, ll int, then we're going to go within that class is where iterator is defined. Hence why we need to use this scope resolution operator. I'm going to call this iterator it, short. I guess it, whatever. So there we go. So if I want to be able to navigate this linked list, well, I would go ahead and say it equals list dot begin. So the function begin, remember, it returns an iterator object whose current is equal to head, and that object that we're going to return will be assigned to IT. So essentially, what's going to happen is we're going to have IT right here. I'm going to use this shape object. So we're going to create, here's our IT object. And it's going to contain this current pointer. I'm going to try to fit the word current right there. Awesome. And it's going to actually point to that. That's what I'm going to go ahead and zoom out so we can see all this. That's what we're going to have. Okay. So now if I were to go ahead and just say cout star IT and L, remember what I told you earlier, star IT is going to overload this operator star for this iterator object. It returns current arrow data. So it's going to return 7. And then of course, if I were to say, so this is output 7, I'll put this over here actually, outputs 7 to the screen. And of course, if I say IT++, like that, remember we're going to invoke or call that operator ++ function. So what happens then is it's going to move current over to this node. Remember what that ++ does, I told you to code earlier. It's going to, that code itself is going to simply have current equals current arrow next. So it's going to set IT's current to the next node. And then of course, if I were to, once again, I could just say cout star IT and L, it would print out 5, because if I dereference the current pointer within this iterator, it's going to access 5. So remember, it's going to return current arrow data, is what that function returns, which returns sort of the data that's contained in that node that IT points to. So that's basically how it works. And of course, minus minus, it would sort of move IT over to the left. So plus plus will move it over to the right, and minus minus moves over to the left. And of course, if I had said IT equals list dot end, that's if I did something like this. Let me put this here. So if I say IT equals list dot end, this function list.end, it returns an iterator whose current contains the tail pointer. So it's going to return that iterator to IT. So IT is now going to be pointing to that node. And of course, I could say IT minus minus to move it over to the left, and so forth. So also in my PDF I have right here, I also go over a little bit of code right there. So if you want to traverse a linked list using a loop, this code does it. You set the list to the beginning. And over here, I created a nil iterator. So nil is an iterator whose current equals null. And what happens is, while IT is not equal to nil, we're going to output IT and IT++. So that's basically, this will one by one iterate through each node in my linked list. So the next thing I'm going to go over now will be the swapNodes function. And of course, I'll go over sort of a, go over sort of a little bit of a pointers as to how to write the main function. All right, swapNodes. Let's go ahead and scroll up for a second and read over the description for swapNodes. Now, of course, I'll use OneNode to draw out the example as to how swapNodes should be implemented. So this will be used for bubble sort, because remember in bubble sort, if this is the first sort you did in CS135, you had to constantly swap adjacent values in a list, right? So we're going to be swapping nodes in our linked list, but we're not going to be swapping just the data fields. We're going to actually physically swap the actual nodes. Let's go ahead and just read this, and then of course we'll do the example. So this function is going to take in two iterators, IT1, IT2, And just to make things simpler, you can assume that IT1 and IT2 will be adjacent sort of nodes, or they will point to adjacent nodes. You also can assume, or I mean, I guess you're going to write bubble sort anyway, but I'm guessing there's no reason why you would not do this, but IT2 will always point to that node to the right, and IT1 will be that left adjacent neighbor, essentially. And this function will swap the actual nodes, like not just that data field, but the actual physical nodes. And at the end, after you're done with that, you want to swap the location of IT1 and IT2. So that way IT1, IT2 still point to the same, I guess you can say, geographic location in the linked list. Let's go ahead and just, first call the function in our example main over here. I won't give you the actual code, but I'll go over, how you want to set this up. Let's go ahead and go back to OneNote. Okay, so I'm going to I'm going to copy this down over here. So I'm going to go ahead and I'm going to take this existing example and then just simply build off of it, just so it's easier to use. This is a good enough example, to be honest, so we can definitely use that. Okay, so I'm going to create two iterator objects, and we can just say, I'll go with this. So let's go with, let's create two iterator objects. Iterator, I'll call it I and J. Obviously, when you did bubble sort, you use I and J indices, I assume, so maybe using I and J right now wouldn't be a bad idea. So then I'm going to set I, so I'm going to go ahead and create the two boxes over here. I'll probably create two smaller boxes. Yeah, that'll work. So I'm going to go ahead and create these two boxes right here, and of course have to paste it way up there at the very top of our OneNote page. That's fine. We can easily just kind of just carry this all the way down to the bottom over here. Perfect. This will be my I iterator. If I make this look like an I, this will be my J iterator. And of course, I'll somehow squeeze in the word current right there and put a small box for that as well. Alrighty. So if I go ahead and I say I equals, I guess I use list. I'm going to keep this. So list dot begin. Then, as you know, what's going to happen is I will point over here, and I'm going to have, I suppose, J will also equal list dot begin as well, like that. And I'll move these two iterators over. So I'm going to maybe move J over, I'll move I over 1, so I plus plus, and I'll do J plus plus once, and I'll do it twice. I'll move J over two times. So what we'll do is eventually this J iterator is going to point to this node, and the I iterator should point to this node. Alrighty. So now what's going to happen is I want to swap these two nodes, but I don't want to just only swap these two values here. I want to actually physically move these two nodes. I want to literally do this. This is my end result. I want to take this 3, put it here, put this 5 over here. I want to just sort of simply move these. This is a very terrible picture, but you get the idea. That's what I kind of want to do, except this looks really hideous, but that is what I'm trying to actually do. Let's go ahead and try to do it step by step. Okay. See, this actually, I like using OneNote. OneNote's really awesome. So there we go. So of course, we're going to go ahead and say list dot swap nodes. I would pass in I and J. So this function body, what is it going to do? Well, the first thing we're going to do, it's up to you how you want to set this up. But what's going to happen is if we swap these two nodes, the first you want to do is you want to have it where 5, its next, should be pointing over here. Now, you might have to declare additional temporary node pointers within this function to actually achieve this result. But for now, we'll go ahead and do this. So you want to first do that. And then what you also want to do is you want to set this node previous to point back over here. And then what you want to do is you want to set this node's its next to point here. I'll use actually, no, I'll go with red. Red's good. Like that. And then, of course, I want to also set this previous, because the idea is that if I'm going to swap these two nodes, I'll redraw this, then that means 3's next has to point to 5, and then 5 has to point back to 3. And of course, you want to make sure that this node, also I'll use blue for this. This has to point back to the previous, and this one would have to point like that. So if I were, it's like having, I don't know, it's like having, you're rewiring the linked list basically. If I were to like lift the head and tail up, then these nodes would rearrange themselves, if that makes any sense. So think of actually having, I can't think of a good example. Think of having, I can't think of an example, but you probably can think of a better example. But it's like you're rewiring the linked list, and at the end, then 5 will point to 8, 8 points back to 5, 3 points to 5, 5 points back to 3, then 3 points back to 7. So you can see how it's nicely arranged like that. Then at the end, what you want to do, just because after you do this swap, what happens is this iterator, so I'll use purple to circle this. I is not going to be pointing to that second node in my linked list from now on. It's going to now point to my third node. So I have to make sure that I still points to that second node after I'm done with this swap operation, because it'll make it much more easier to write the bubble sort algorithm. So at the very end, what you want to do is you're going to want to basically make sure that, I'll use yellow now, I'll use red, I guess. You want to make sure that this J points over here. You want to make sure that I's current points over there. So as you can see, very simple. I mean, it's not really any code that would drive you crazy, or even this picture, it looks so amazing. It looks nice. You can see how obvious this is. And I guess the beauty of algorithms data structures is that this sort of approach is actually just as efficient as if I were just simply copy 5 and 3 over like that. Now, this method actually is a much more efficient approach actually to swap two nodes. I mean, so suppose that, what if these two nodes were not integers? What if we stored vectors into each node, or some bigger data amount? Then possibly doing a swap of actual data fields would take maybe more runtime. It would take more time actually than to actually just rewire the linked list. So maybe I could sort of explain this later on as to why it's the case. But anyway, that's how you want to write the swapNodes function. But also you want to be careful to make sure you also check for, well, what if I or J point to the head or tail? You want to make sure that the head and tail still point to the head and tail. So if I were to swap 7 and 5, for example, so what if I were to swap, let me go ahead and use maybe yellow pen. What if I swap, oh, you cannot see that, so I'll use purple. If I were to swap 7 and 5, or actually now it would be 7 and 3, my mistake, we get the idea. Then after you swap, the head has to point to the new head node, because the node that was to the right of head would be the new head node, if that makes any sense. So you have to have some extra sort of edge cases also, because you could have I and J could point to head or tail. But this is sort of my explanation as to how to implement the swapNodes function. So last thing I'm going to do now is I'm going to just go over the main sort of portion, but there won't be too much to discuss with main. Let's go ahead and discuss that next though. All right, let's go to the PDF one last time. So basically what you want to do is you're going to write this bubble sort, and it's going to be very similar to what you did in CS135. The only difference is you're not going to be using integer counters. And in fact, you are not going to be using any counter control loops. That would be loss of points. So you want to use, you can use for loops if you want, but they cannot be counter controlled. So you have to use iterators, and once the iterator reaches a certain node, or either it hits null or hits a certain node, you stop the inner loop and you go to the outer loop and so forth. I actually did link over here. Let me go over here for a second. I did link the pseudocode for actually the Geeks for Geeks link for bubble sorts. Let's go ahead and just, I guess I'll leave, I suppose. Okay. Bubble sorts. So, I mean, you know, here's the C++ code for it. Yeah, so here's your outer loop, here's your inner loop. So you have to write this, except I and j are going to be iterators. They're not going to be integers like this. And when it hits the end, well, the end might also be some special iterator as well. So you have to find a way to use iterators. So once I hits the end, you're done. Also the j loop, j has to hit a certain iterator. That's how you know you ended that inner loop portion. And the outer loop also, it will have some special case when iterator reaches a certain special iterator, it's going to stop and then continue like that. And then swap would just be simply swap nodes. You'd pass in two iterators into the function, and if assuming the swap nodes does work correctly, you know, this is really all there is to this bubble sort sort of code, I guess you can say. So let's go ahead and go back to the let's see here. Let's go back to the write up. Let's go to a light theme over here. So pretty much all you're gonna have to do in your program is you run your program. It'll just be, you have to of course compile your code. So what's gonna happen is in your header file, you're going to, of course, here's how you're gonna set this up. So I'll say it's right here actually. You're gonna have all of this copy and paste into your header file. And you're gonna put all of these function sort of implementations also in your same header file, because for some reason C++ is not able to externally link an implementation and a main to a header file if you have a templated or a class template. So you'd put all this into your header file basically, and you would include a header file into your main. So you'd only use G++, your main file, essentially to compile. And your program, once you're running, you prompt user for file name, enter a file name. You can assume that the file name that will be entered will be a valid file name. You output the string original list, which will be what this is the list that's in that file. Then you can output the word sorted list, and then output the list in sorted order. And there'll be other files we're going to use as well. But for code grade, make sure you prompt the user exactly this string. Then you write this. Then the numbers. Now, I actually have it on code grade where I ignore all white spaces to make it much more simpler on you, because I know code grade will check for some random bizarre character, a hidden character in the output, and then it will mark your program incorrectly. So I have it ignore all white space just to make things a lot more easier. So let's say if you have no line, if you had no extra space between these two, it's not going to matter. If you put it actually one number per line instead of like this listed out, it will still work. It will just check for the actual non-white space characters. It will check for when it does the comparisons. So that's basically the assignment 1. So I guess happy coding. So till next time.